Good afternoon, and welcome back. It's a pleasure to be with you. My name is Fadi Farra. I'll be facilitating this session on advanced manufacturing and new materials with distinguished speakers, which are all here on my left. But before we get started, let me set the stage a little bit on this topic. Advanced manufacturing and new materials is a bit like a pyramid. You cannot go to the top of that pyramid with any new material or new processes without having the fundamental capabilities in terms of human capital, in terms of infrastructure, access to finance, to then move up a level and having the right innovation strategies at the corporate level or the organizational level. And once you have those two basics, you can probably move up to the next ladder, which is new materials and impact on new types of methodologies, processes, and so on. The basic objective of this session is to find out why is it that we still build planes the same way we used to build them 30 or 40 years ago? How will those planes or others be built in 10 years, 20 years, or 30 years? What type of material? What type of processes? And to address some of those questions, I have with me quite a distinguished list of speakers, starting with, on my left here, Stephan. Walter is the chairman and chief executive officer of Fischer Advanced Composite Corporation. He's based in Austria. And his company specializes in the design, development, and manufacture of plastic lightweight components for the aviation industry. He has more than 30 years of experience in this industry and is a graduate in polymer engineering from the Institute of Materials in Austria. Second speaker, I'll move, thank you, to Eric. Eric is Chief Operating Officer of Alcoa Investment Casting, Forging and Extrusion. In his new role, Eric is responsible for Alcoa Power and Propulsion, Forging and Extrusion, oil and gas and defense industry. He's on the executive council of the company, and he served as president of Alcoa Forging and Extrusion up to 2009. Next to Eric, we have Badr Olama. Badr is Senior Vice President of Mubadala and since 2005 and Chief Executive of Strata. He's been instrumental in developing the aerospace cluster in Al Ain, Nibras, but also instrumental in developing a company that now is a leader in Abu Dhabi in composites, in advanced composites, with I think contracts of up to 2 billion, and probably moved up now to 5 billion or something of the sort.
7.5 in total.
7.5 billion, so it keeps moving up. And a fellow Harvard graduate. Next on the panel, we have Fleming. Shane is the chairman of the board, president and chief executive officer of Cytec Industries. He previously served as president of Cytec Specialty Chemicals and was elected to Cytec executive leadership team in September 2004. Long-standing experience in the aerospace industries, started in technical service engineering with a number of positions in Cytec, and fuel engineer from the University of Utah. Last but not least, Osman Okyay. Osman is the president of the technical division of the Kale group. I think one of the results of the superb experience of Turkey in this industry. He's not only a mechanical engineer and an expert in this area, but he also operates outside of the company as chairman of the Turkish-American Business Council, the Turkish and Dutch Business Council, the president of the Aerospace Cluster Association in Izmir, and the chairman of the Chamber of Commerce and Industry of Çanakkale in Turkey. Thank you for being with us, and I'll start off that straight away with a question to you, Walter. We're talking about new technologies. Your company has been quite instrumental in developing complex and new technologies. what brought you to develop such technology? What type of capabilities got you to lead in this area?
Yes, good afternoon, ladies and gentlemen. I'm representing FACC. Good afternoon, ladies and gentlemen. I'm representing FACC. My name is Stephan. Interestingly enough, our technology came from sporty goods industry. That was the first industry used advanced composite materials. I'm coming from a comparable young company in the aerospace industry. Our company just is 25 years old, but in those 25 years we have grown with an accumulated 22% year-on-year growth rate. And it was innovation who brought us to this point. First of all, it was innovation on technology, and secondly, it was innovation on the business model. I'll just start with a little bit of an insight into technology on the material end and the processes end. I think we are a small company still with roughly 760 million US dollar or 540 million euro, but we have been the single largest company, I think, to build a composite wing together with a customer in recent years. It was a composite wing for 150 to 220 seat airplane, and it was the first composite wing which was built out of an autoclave, with an out-of-the-autoclave system in a partnership, for example, with Cytec on one hand, at the same time in a partnership with our customer who has done basic design work and who has afterwards done the testing and the redesign, so this airplane this wing will fly eventually on this 150-seat airplane. I think in this technology program, I think we have worked on the trends in composites, the trends in aerospace, and I have to say, aerospace is the biggest trend in composite is the biggest trend in aerospace these days. We have worked on this trend, and this cost reduction. And cost reduction can be reached by reducing the cost of the material, by making a much larger, bigger portions of composites in the future, and secondly, by automating all processes surrounding the aircraft manufacturing. I think the composites today are capable of reducing price. They are increasing the performance of the aircraft, and there are good examples right now. I think just to name the A350 XWB as well as the Boeing 87, with having 50% weight in composites, I think they reduce the noise footprint today of the aircraft by 60% compared. They reduce operating costs by 20%. So that's the technology, and we are concentrating really there on automatization of every process involved in it, and that's to some degree quite delicate, I think, to work on that, because as you know, safety is the highest thing in aerospace, and I think all processes need to be qualified, and that's a major challenge. The second, I think, is we have a very novel business model. We are coming from Austria, which is not very strong in aerospace, small population, so we don't have a home market. So we based our business model on working in a huge global network with our customers, and in this respect we came also to the United Arab Emirates, working with Strata in 2008 and helping Strata build up the composite capability. I think we signed our first contract in 2008, and between 2010 and 2011, Strata was capable of building up a brand new composite facility in Elaine, and at the same time qualifying, I would say, everything within a time frame between 18 to 24 months. And right now they are proceeding, I think, with a rate of growth in the range of 30%, I think, due to the heavy market. And I think this business model, I think, is kind of interesting, which we have, because it's more or less using a similar model like is used in the hotel industry.
Thank you. We'll come back to the question of the Middle East, but you're talking about enhanced composites, more efficient, less costly. But what will be the next generation? What could be ideas about what will come after that?
I think composites have a long way to go. I think the first real composite application was the 787 with exceeding 50% composite content, and this was a dramatic breakthrough because original aircraft had between 5 and 20%, and those goes to the 777 aircraft, which is a very advanced aircraft, and the A380. So it's a breakthrough, and I think the industry is currently working on the automatization, and I would say we are looking into other segments, other industries at the moment, and naturally there's the automotive industries will bring the composite industry to perfection, so we can move, and I think Shane Fleming has a little bit more on that, on the material properties which are ever increasing in the past years. Mm-hmm. And we can move on the same time automatization in non-destructive testing, automatization in the layup of composites. That the major issue is to have many kilograms of composites brought more or less into the production process in the shortest time frame possible in order to avoid labor costs and in order to have the quality of the component after that.
Thank you. You're pretty much at the top of that pyramid. How do you see markets like the Middle East evolving in terms of capabilities?
I think for sure the aerospace industry is a very interesting industry segment because it's the only industry pretty much which grows in the next 20 years with 5%. The Middle East as such, they have growth rates of 12% roughly. And I think the replacement of metallic components on the new generation of airplanes gives them the capability of having growth rates a bit upwards of 20%. I think there's an opportunity for them to participate in the growth of the traffic, in the growth of the materials, of the composite materials, as well as they will be a big portion of a potential consolidation cycle, I would say, which needs to take place in this industry, in aerostructures industry, in the next couple of 5 years, I would say. It's only possible to consolidate with consolidation in aerostructure industry.
Thank you. Badr, I would like to move to you. For some of you that did not visit the airline plant, I encourage you to all see it because it's quite impressive. And Badr has been heading the success story in the UAE, in Abu Dhabi and the UAE. How did this happen? How did Abu Dhabi, the UAE, build Strata, build such capabilities?
That's a good question. To be very fair, we started off with a vision. We started off with a strategy that came in. And that was under the Abu Dhabi Economic Vision 2030. The Abu Dhabi Economic Vision 2030 had a number of different pillars, of which it had to do with a strong private sector, a knowledge-based economy, fostering international relationships, as well as enhancing the UAE's federation. And taking those pillars and taking those objectives, putting it into a plan of diversification. In terms of our GDP, we identified aerospace as a potential opportunity for Abu Dhabi, considering that CapEx wasn't an issue, capital expenditure, considering that we did have power resources that was available to be deployed again in projects. So taking all of that, identifying a key partner and a customer such as Airbus, which eventually introduced us to FACC, and putting all those efforts together to actually build up a capability that I believe a lot of people didn't think it was possible in this part of the world. You consider it's hot and humid. You consider that it is quite dusty and sandy. Manufacturing in aerospace was something that was unthought of. And then to turn all of that into a success story. And the success story that we have is over 600 people, of which 40% are UAE nationals. Out of the 40% that are UAE nationals, 80% are women. And out of the ladies that we do have, 95% of Emirati women are actually contributing to revenue. They are the ones that are making the product. So we've translated that into a success story. And I always like to say that if, for whatever reason, we were unsuccessful, the last Dubai Air Show proved otherwise. And we tripled our order book, or our commitment book, from Airbus and Boeing. So from 2.5 billion, we've grown to 7.5 billion. That says something. Now, the future is even more challenging because at the moment, we've established a manufacturing culture. People understand the importance of being in a global supply chain. People understand that this is serious business. We have to deliver on our commitments, and when we are delivering on our commitments, quality is a fundamental area of concern. So the way that we've tackled it again in our kind of environment, we have to educate the workforce to make sure they understand that people, 500 people or 525 people in the case of an Emirates 380, are flying on products that we manufacture, and we cannot compromise their safety at any cost. The next stage is to see what is beyond Strata 1, what is beyond Strata and Al-Ain. Is it a global supply chain? Is it something that we will look into expanding beyond the boundaries of the United Arab Emirates? Maybe into low-cost economies, maybe into economies that are closer to our customers, such as Boeing and Airbus. But that is the next stage of evolution that we see for Strata going forward.
If we come back here in 10 years' time, what type of material could be built or assembled here?
Composites for us was a no-brainer. As Walter mentioned, the market is going towards composite. The composite content on aircraft is seeing an increasing trend. But maybe I disagree a little bit with Walter in the fact that what does the future look like? And the future, you can't predict. You know, did people predict that composites would replace metallics to the extent that it has? I don't think so. There are talks about self-healing materials. There are talks about using, fiber optics. The question is not posed to us. The question is posed to the customer, the airlines. What does the airline want to see in their products that will drive Boeing and Airbus to actually invest in new technologies, which will again flow down to people such as ourselves? The suppliers, FACC in the future, Strata, are the ones that are going to innovate to meet the expectations of the end user, the customer. Now, obviously, I've said this in a previous conference. It's actually a nice win-win circle. The more people travel, the more travel is affordable, the more planes are required. And the more planes that are required, that means there is more business for us. So we have to, in essence, find what is it that we can do to make flying more affordable.
Thank you. Badr, I would like to pass on the floor to Osman to share with us, talking about the basic capabilities that you built in Turkey and the success story of Turkey. How did the Kale group appear? How did you start developing the materials that you're developing at the moment? What type of innovation strategies did you have?
Right. Thank you very much. And hello, everybody. Assalamu alaikum for my UAE friends. I represent a company that is, you can call a traditional family-owned industrial business. Our company was established back in 1957 to make ceramic tiles. And for the first 40 years, that's what we did. And after I joined the group, we made a study, and we looked for areas to diversify. And but we also had a small company called Kale to build molds and tools for the mother company, which had a precision machining capability. And I took that company personally, actually, and diversified into defense and aerospace field. Because we had two basic capabilities which was required by the defense and aerospace industry. One is precision manufacturing, and the other one is tooling and fixturing. So we, our first project was the Eurostinger program that we got on board with back in 1989. And since then, we've been developing our business in both in defense and aerospace. Today, we have three companies that works on the aerospace field, and one in defense. And our Kale Aerospace is one of the aerospace companies we have, where we build structural parts for the world's largest programs, like F-35 is one of the most important programs and that we have a lot of work share for. And so we work with Lockheed, and both for the aeronautics division and for their missiles and fire controls division as well. For Boeing, we also build lots of parts for 737s and 47s and 777s. For Airbus, we build fuel tank parts. So they're all machined or sheet metal parts, and with some sub-assembly as well. So besides Kale Aerospace, the second company we have is our recent joint venture with Pratt & Whitney. We build engine parts, jet engine parts, mainly for F-135 engines, again, one of the latest jet engines developed by Pratt & Whitney. So it's a greenfield operation. We started our operation beginning of this year. Our plant is up and running now. The third division we have is a little joint venture with a Turkish company where we design and develop UAVs, indigenous design work we do there. And we have quite a few UAVs that is operational in the Turkish Armed Forces and some of the other friendly countries' armed forces. And we have several different types, mini UAVs, tactical UAVs, and rotary wing ones as well. Those are the three aerospace companies we have. We also have a defense company where we design and build small arms. We are given the task to design the infantry rifle for the Turkish Armed Forces, which is actually NATO's second largest armed forces. So we will be designing and building rifles for the Turkish army and for other friendly armies as well. So machine guns, infantry rifles, we design and build in our defense company. We also have an R&D company which is separate than those, where we, which serves actually to the other three companies we have. And we got awarded to design a new small turbojet engine for a Turkish cruise missile. So right now we are working on that project as our R&D department. So these are the internal projects that we undertake currently. We also have projects that we partner with Turkish universities and research institutes, such as energy storage and power systems projects, such as lithium-ion batteries with advanced capabilities, and fuel cells, different type of fuel cells. Again, which is actually which could be used both commercially and military. So as Kale Group, we believe the old-fashioned growth, which is you get your people, you train them, you build your infrastructure, and then you grow sustainably. And so that's how we set up our structure at Kale Group. But we're also very keen to open innovation as well. So we do cooperate with other institutes and other companies as well for research and development projects. So this is, in a nutshell, what I wanted to say.
Thank you. So clearly building strong capabilities in Turkey, and I assume based on the public initial investments and the public program initially. I would like to move to Shane from Cytec, to tell us maybe what would be your advice for emerging markets willing to develop new materials and develop further in the aerospace industry.
Okay. First of all, I'd like to thank Mubadala for the opportunity to participate in this panel and say good afternoon to everyone. Cytec's been in the advanced materials business, believe it or not, for over 50 years, and today I would say we're one of the leading companies in terms of the development and the manufacture and the application of carbon fiber reinforced materials for particularly the aerospace industry. So to your question on emerging economies and the development of capabilities around this types of technology, I think Badr touched on quite a bit of it. I think the opportunity is to reach out to and network and build partnerships, collaborations with leading companies around the world. We like to think that that partnership that we've developed is in that same category. I think there's a real advantage in some ways for new entrants into the market because you don't have the sunk capital or the organizational attachment to older technologies. You're able to leapfrog to the latest, newest technologies. Walter talked about the use of more automation. I think that is really the future in the production of composite parts for aerospace and for other industries as well. So close collaboration with industry leaders is really, I think, the primary path to follow for success, particularly if you're trying to accelerate up that path.
But then what are the major challenges today to have further adoption of composite material in the aerospace industry?
It's a long list. I could probably talk for the next 20 minutes about the challenges. I think the aerospace industry itself, because of the safety concerns, is a special industry. It takes a long time to learn how to operate effectively in that industry. And I think, again, the example of Strata is they've accelerated up that path much more quickly than most companies. So they've got that piece, I think, pretty well under control. But then as you look forward and want to broaden your capabilities and make the business larger and participate in bigger applications, primary structure type applications, there's a lot of technology and how you manufacture the materials. I think there's a lot of good decisions, capital decisions that need to be made about what type of infrastructure you build, what technologies you bet on for the future. I believe we're in a really exciting time right now for the use of carbon fiber materials because we're transitioning away from what historically has been kind of niche markets, including aerospace, to bigger applications. Walter referenced 50% composite content on the new planes, the 787 and 350, but we're also seeing those same advances in usage in a number of industries. And to make carbon fiber value proposition really work, one of the real focuses for us, and I think for anybody in this value chain, is to figure out how to increase rate, reduce the amount of labor requirements to produce these parts. So making more automated manufacturing a reality, getting the quality control that will allow that to happen. So what we're trying to do to facilitate that is purposely produce materials that translate well into those types of applications. I think Walter referenced the wing application that we've jointly developed using a resin transfer molding type of technology, so not the typical pre-preg layup, highly labor-intensive type process. So a lot of our R&D focus, a lot of our innovation today is on developing materials that lend themselves to automated tape layout or automated fiber placement or resin transfer molding type applications where you can get the rate and the quality to reduce the total systems cost and then allow the industry to continue to grow and displace more metals for the future.
The multifunctionality of material is a growing focus in the industry. How do you see this going?
Well, one of the challenges when you use carbon fiber materials is that you have problems that you don't with metals. For instance, sound dampening is an issue, lightning strike protection is an issue. So to overcome that, again, some of the development work we're doing today is to build that multifunctionality into the carbon fiber materials themselves. So that's a major R&D focus for us, is to build that functionality in so you don't have to add extra weight, parasitic weight that takes away from the advantages that you get with carbon fiber material. So that is a primary focus for the industry.
What I'm hearing basically from you and Walter is we're still going to go towards the composites, but just more efficient, multifunction. Eric, if I may turn on to you, thank you, Sean. You build the metal which is basically behind that plastic. What is the future of metals?
Okay, well, first off, thank you very much to everybody and to Mubadala for hosting, and good afternoon. You know, at Alcoa, we view innovation not as an episodic event, but as a generational process. And as such, our journey of innovation in aerospace actually started in 1903, when these two crazy brothers came to Alcoa and said, can you actually create an aluminum alloy that we can make an engine out of for the engine block? Since then, with Alcoa metal flying on the first Wright Flyer, over 110 years, it's a relentless pursuit of innovation that has led to some of the most amazing breakthroughs in aerospace. One of the ones that we're known for, over 90% of all the alloys and tempers in aluminum that are flying anywhere in the world today were developed by Alcoa. And in that process, what we've done is grown a $4 billion aerospace business with 54 locations in 12 different countries. And we play everywhere in aerospace. We're in commercial defense space. We're inside the engine on the airframe. We're in metallic heavy aircraft. We're in carbon heavy aircraft and in hybrids. And one of the messages you'll get from me, and I think from the panel, is there is no such thing as a metallic or a carbon aircraft. Every aircraft is a hybrid. And the key to success, and where I think innovation will be seen the most, is in bringing the best of all technologies together to solve specific problems. Now, across that $4 billion of revenue, we really have three legs. 1/3 of what we do is in what we call fastening systems. Think of the titanium sleeve fasteners that hold your carbon fiber skins together and also are the solution to the lightning strike problem. Another third of what we do is in nickel and titanium investment castings. We make the airfoils, the blades and vanes, inside the hot section, so the high pressure and low pressure turbines, of actually every single Western jet engine. And finally, structures, which we tend to be known for because it's quite visible, but that includes nickel, titanium, aluminum forgings, castings, all the way through advanced aluminum and lithium alloys on sheet and plate. Very specifically, though, let me give you a few examples of where materials and manufacturing come together to solve some incredibly challenging problems. The first one I want to hit on is rapid prototyping. We've talked about additive manufacturing. In the investment casting world, it's a technology we've used for over 20 years because we can use additive to print up patterns and molds. So you can go to a General Electric, a Pratt, or a Rolls, and very quickly give them an example of the latest cooling cores into the platform, thin trailing edges, cast in holes, have your own coatings, and through that process, give them the ability to tweak and change. With additive, what we're seeing is not only a way to more quickly print patterns, you can also print up tooling, and occasionally you can print up parts. They don't all have the properties, particularly fatigue, that you would require in the end item, but it gives you a chance to play that's been unprecedented and is going to open up great doors. The next technology I want to talk about is parts consolidation through monolithic structures. You see this in very, very large wing skins, whether they're carbon fiber or aluminum. But if I use an example on the F-35, by being able to go to a huge structure, think over 7 meters long by 2 meters tall by 1/2 meter wide, across the 6 main bulkheads, titanium and aluminum, by getting rid of all of the assembled structure, you're able to take out over 200 kilograms from a fighter. Think about how many $1 million a fighter plane is willing to spend to get even 1 kilogram out. Take 200 out and have a solution installed on the aircraft at a 20% lower installed cost. In a way that marries the carbon fiber skins on top with the metallic structure, with the fasteners that can bring it together, that can handle galvanic corrosion, thermal expansion, and lightning strike all at the same time. So in conclusion, what I would say is that the future of innovation is when you can bring all those pieces together and continue to advance each generation going forward.
Thanks a lot, Eric. And probably to push it a bit further, to put those pieces together, how about across industries? What if we had to look at 3D printing? What if we had to look at other type of technologies? What could be adopted in your companies to go to the next level?
Well, it's a fantastic question, and it's one of the real joys and blessings I have working at Alcoa, and we all do, is that we have a little catch line inside the company. If it moves, we're on it. And it's pretty much true. In fact, another crazy thing to think about is if you are looking at something made out of aluminum, it probably was not originally designed in aluminum. It was something else first. From the wheels on your car, to a can in your hand, to the backs of your iPhones. And it's by being able to share technologies across these different platforms, different markets, different product forms, that you can really rapidly accelerate innovation. We have one right now where work that we had done with military armor, coupled with manufacturing techniques in aerospace, have now enabled the biggest single material shift in the automotive world in North America, where finally you're seeing the aluminization of vehicles like pickup trucks. That was a huge shift. If you've got your iPhone, think about that. What was always a plastic case, well, one of the big issues as you pack more power into these guys while still keeping a good look and feel is thermal dissipation. Guess what happens when you finally have an aluminum structure that meets all of the requirements? So by bringing that all together inside of aerospace and other markets, you see great synergy potential.
Thank you. I'll ask one question to the entire panel, then open up to the floor. What will be potential new advanced manufacturing processes that could be imagined over the next 5 to 10 years based on potential new material, new ideas? Maybe Walter or any of the members of the panel.
Yeah, I think that's a critical issue for the industry. If we want to continue to penetrate new applications and add more content to the aerospace industry, the way that materials get manufactured, the way carbon fiber reinforced materials get converted into parts has got to change. So we actually made a fairly sizable acquisition for us about 18 months ago. We bought a company that their primary market, in-market, is automotive rather than aerospace. And the reason we did that is because they've got prototype part manufacturing capability and applications engineering capability focused on reducing cycle times. You know, in an airplane, when you're building 30 or 40 a month, you can live with 24-hour cycle times to build parts. But when you're talking about tens of thousands of cars per year, you've got to get cycle times down into the minutes. So our view is that we're going to invest heavily, collaboratively with the OEMs and the automotive market to develop some of these manufacturing technologies. And ultimately, I think they're going to find their way back into the aerospace industry because it's going to take cost out and add quality. And I think that is a big, taking cost out and getting rates up will really facilitate the use of greater composites across a whole host of applications.
Thank you. Briefly, yes, please.
Okay. One technology that I think we're all going to see a lot more of is what we call the digital thread, meaning that in aerospace, what we all do is provide a quality guarantee. So from the beginning of a component through a final assembly to be, as we have more automation and more data collection, to be able to track that, stamp it, have it all digitized and all recorded, not only really helps with the quality guarantee because you can immediately track back to problems, but that data can be used for huge productivity improvements in the manufacturing process.
Thank you. We have time for one or two questions from the floor. So I see one here, I see a second one here, so there we go. If there's a microphone, if someone can, if there's someone with a microphone. I guess the microphone went for lunch. You can always try and shout, but hopefully there's a microphone somewhere here.
Yeah.
I'll probably repeat the question, absolutely. If you don't mind holding, there's the microphone coming. Yes.
Yeah. Of course, I will repeat, I'm very proud that Strata has, let's say, integrated into the stream of the supply chain for the high-tech industry, especially in the aerospace. I would like to know, what component do you manufacture now? Sure. Basically, as far as I know, it's probably the fairing for the flap fairings and extra. And for Eric, where do you see the future in manufacturing? I believe we would go into the 3D or 3D printers. Does it will come handy in any of your components in the future? And what effect will have on the quality of the product or material?
So just before you respond, if you don't mind, so one question on Strata, one on 3D. I'll take the one from a gentleman here, and this way we can all answer after that, please.
Okay, if you want to add to the group. So in the space applications, use of carbon composites is quite challenging because of micro-cracking due to coefficient of thermal expansion problems. However, in fluoropolymers, it's a very interesting topic to discuss. So I was wondering if any of the composite manufacturers are doing any work in fluoropolymers for tanks.
Thank you. So first on Strata.
So that is a very good question, and the reason I want to answer it a little bit differently is, it's Manny? So the way I want to answer that question is, people ask me, are we still manufacturing fairings only? And fairings was a good starting point for us. The reason why it was a starting point is because you cannot start manufacturing complex integrated parts using automation unless you have done something that is simple, straightforward, using your own hands. We've started off with fairings. We focused our products mainly on the wing movables, so we do spoilers, ailerons, and empennage ribs, but our main objective is to focus on the empennage part, whether it's the horizontal stabilizer or the vertical fin, and that's where we're heading.
Thank you. And the question on 3D.
Okay, so we completely believe that additive manufacturing is going to become a significant tool in the manufacturing toolkit. I don't think we're ever going to get to a world where every metallic part is printed, and there's some physics behind that. But the places we see it really entering the workflow probably the soonest is in prototyping. So printing up parts initially for rapid prototyping, printing up tooling, also enabling rapid prototyping. And then when you get into non-load bearing components, particularly for a very high valued, high temperature metal like a nickel and a titanium, where I mean, the biggest problem that is going to have to be overcome in additive is, can you have the fatigue performance in a load-bearing part, whether that's structural and certainly in any rotating part. And that's something the industry is going to take some work to figure out.
Thank you. On your question, yeah, please. On that question, any further thoughts?
Sorry, can you repeat that second question?
Sure, go ahead.
So my question was about cryogenic applications, and carbon composites aren't very good for that because of the coefficient thermal expansion problem and microcracking. And so I was wondering if anyone had been experimenting with fluoropolymers. We've done some work in that, and it was quite successful, but you know, we aren't a composite shop, so.
Yeah, I'm not close enough to all of our fundamental R&D to say conclusively one way or another that we are looking at fluoropolymers, but we are looking at that issue, thermal expansion issue, with a number of different types of materials. I heard somebody, I think on the earlier panel, talk about their view that in time you're going to see nanotubes and graphene type materials being used, and that is an area that we're pursuing today, both doing our own fundamental research and also collaboratively with some university programs, because we do believe there's a future for some of the reasons you mentioned.
Very good. Thank you. I would like to thank the panel for the insights. Clearly there's a composites. That's the time where basically we have to end.